How far with the board now? How far with the board now? Is it clearer now? Is the board clearer now? Okay, good. Where are the others? Where are the others? Where are the others? Where are the others? We are live now. Where are the others? Where are the others? Where are the others? Yes. Where are the others? Where are the others? Please, the board. Right? Yes. Yes. We have 5 people. We are 5. We are now 5. Where are the others? Where are the others? Please, if you're just joining, you have to subscribe to our channel. Go and subscribe. Anytime we come live, you will be aware. Anytime we go live, you'll be aware. Go and subscribe to our channel. Hit the subscribe button below. You see a subscribe button below. Hit the subscribe button and join us. Okay, we are now 10. We are now 10. Where are the Telegram people? Where are you? Where are you? Where are you? We have 10 people live now. So I'm about starting the class. 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 Yes. We are live now on YouTube. Go to our YouTube channel and join the live class. We are 15 on the group now. Please, can you confirm that you can hear me? Can you hear me clearly? Can you see the board so I can start? Give me the go ahead to start. Give me the go ahead to start. Give me the go ahead. Can you see the board clearly? Yes. Michael said active. Yes. Maxi said good evening. Yes. Where are the others? Where are the others? Yes. Okay. Michael said wait for more people. Wait. Okay. Yes. Okay. Someone say yes. You can start. Someone say wait for more people. Okay. Let's set a number target. Once we hit 30 students, we'll start. Once we hit 30 students, we'll start. You're welcome. Good evening, Joy. Good evening, Osade. Welcome back. 22 people are live now. Yes, blessing. Omoyeni, welcome. Yes. Please share the link to all your department groups. Let everybody just come online first. Share the link. Share the link. Tell them class is ongoing live. Physics. Live class. Yes, Frank said I'm here. We can start now because you don't reach Abby. We can start now. Someone said I can hear you, sir. The board is clear enough. Good. Glorious. Good. Glorious. Say good evening, sir. Obina Emmanuel. Good evening, sir. Yes. Okay, wonderful. We are 30. We have 30 people on live now. Yes. Remember, we give an assignment. That's why I want most people to be around so that when we're doing the assignment, they'll not draw them. We give an assignment. Please share the link. Some people might not know I posted the link on our group. Share the link. If you're on Telegram there, go to the YouTube and join us live. Share the link. Please, once you come in, drop a comment. Let us know that your presence. Yes. Please. If you're just coming, you have not yet subscribed to our channel, go and hit the subscribe button quickly, so that it will be easier for you to know when we're live. Easy. Good evening. Say good evening, sir. Good evening to you too. Yes. Yes, Salvation said good evening, sir. Yes, good evening. Please, this today's zone, make sure you don't come and then you just go like that. Please, no, let's be serious. Let's be what? I've already given people a pep talk yesterday. So please, let me not do another. Let us be learning. Don't say anything. Go back. Stop. Please, I'm going to the board now. I want you to let me know. Can you hear me from the board? Can you hear me from the board? Today I'm using my mic. Can you hear me from the board clearly? Can you hear me from the board clearly? Drop a comment. Let me see. Can you hear me from the board clearly before I start? We're looking at the assignment solution first. I gave an assignment. I gave 2 assignments yesterday. Can you hear me board clearly? Yesterday. Yes, Max. Yes, we can hear you. Please, please, please. Yes, yes. David Donald said yes. Blessing said yes. David said yes. We can hear you. Well done, well done. Where are the others? Yes. 9 people, and we have so many people that have registered. We've posted this link everywhere. Where are the others? Where are the others? Once I hear you loud and clear, good. Please let us take this serious. Pause all your other social media. Put your phone on do not disturb. Put your phone on do not disturb. Remove all of that. Close all tabs on your phone. Your close all tabs and concentrate. Get your writing material. Get writing material. Write all tabs and concentrate. Close all tabs and concentrate. I want to start now. Anybody that comes in will join. We are 40. Yes, good. I like the number now. Good. We are 40 live. Please don't just come in and go out. Please. You are here to learn. School is resuming on Monday. There is no again. School is resuming on Monday. There's no time again. Thank you. Thank you. 13 likes. Thank you. Thank you. I'm seeing those that are like the post. Thank you. When you like it, YouTube, to tell YouTube that this person is yes. This channel, please give them more clearer live videos because they are serious. Yes, 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 yes. Okay, let's start. Let us start. 14 likes. Thank you. Thank you. Those that are liking the video, thank you. Thank you. Thank you. Thank you. Okay, let's start. Let's start. Let's start. Let's start. Let us start. Let us start. Let us start. So we gave 2 questions yesterday. Just to be clear, my marker was not very clear yesterday, but I'm fully ready today. I filled my 3 markers. The first question said a body of mass. In case you didn't join today, I believe you've watched a body of mass, 6 kg, moving with a speed. A body of mass, 6 kg, moving with a speed of 20 meters per second, is suddenly hit by another body. Is suddenly hit by another body, moving in the same direction. Moving in the same direction. They said thereby changing the speed. Thereby changing the speed of the former body to 50 meters per second. To 50 meters per second. What is the impulse received by the first body? What is the impulse received by the first body? This is the first assignment we gave yesterday. I hope you are still with me. I hope you're still with me. I hope you're still with me. This is the first assignment we gave yesterday. How many are we now? We are 42. We are 42. 42. Where are the others? Where now? So everybody can follow up. Yes, 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 yes. Yes, 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 yes. So this is the question. In case this was the question that was given yesterday. So we said a body of mass 6 kg. A body of mass 6 kg moving with a speed of 20 meters per second is suddenly hit by another body moving in the same direction, thereby changing the speed of the former body to 50 meters per second. What is the impulse received by the first body? What's the impulse received by the first body? Thank you. 24 people have liked our live class. Thank you. Those that are hitting the like button, thank you. If you're not yet a subscriber to our channel, hit the subscribe button too. Hit the subscribe button. So that anytime we go live, it will be easy for you to know. Your phone will notify you. Your YouTube on your phone will notify you easily. Are we together? That's why you should be a subscriber on our channel. It's not when you hear subscriber, it's not money. So when they hear subscribe, I think it's money. No, it's just to hit the subscribe button, just like you're following us on YouTube, just like you're following someone on Instagram. You need to pay to follow. No, just to subscribe, like be a member of. So anytime we post videos, you easily know. You easily know. You easily know. You easily know. Yes, yes, yes. 46 people live now. 27 people have liked our video. Thank you, thank you, thank you. Please, those that have come on live, make sure you stay in the class till the end. So you don't need to go and start watching it. You know that you're already live. You are watching together. We encourage each other together. Do you understand? It's easier. But when if you miss the live class and you go and watch it later, the motivation to watch to the end might not be there. For you will just give up, or on that thing will distract you. But when you're watching with your fellow colleagues, there's this class feeling. Okay, we're in class, and we push each other. Let's get the ball rolling. Now, this question was from Newton's second law of motion. Remember, we studied Newton's second law of motion yesterday. I believe if you are new here, you should have watched the video of yesterday's class. Newton's second law of motion is so-called law of momentum, right? The law of momentum, and it states that what? The rate of change of momentum is proportional to the applied force. And this takes the direction of the what? Of the force. Mathematically, the implication of Newton's second law of motion, the rate of change of momentum is minus u. Implication, the mathematical formula for Newton's second law of motion. This is mathematical implication for Newton's second. Don't forget that the topic we are dealing with is dynamics. Dynamics. And we defined dynamics yesterday as the study of motion with reference to the cause of motion. There's a reason why a body is moving. So we study why this body moving in this direction. In dynamics, we try to study why a body is moving in particular direction. What motion to move. Now, so if you this is the Newton's second law of motion formula. F represents force, final velocity, U represents initial velocity, and T represents time. F represents force, M represents mass, V represents final velocity, U represents initial velocity, and T represents time. Now, class, very important. But if I'm to take this formula, this numerator, mv minus u, this formula up represents change in momentum. What? Momentum have mv minus mu. And anytime you have mass and for momentum. So mass times final velocity is final momentum. Mass times initial velocity is initial momentum. And this minus is the difference between the final momentum and the initial momentum will give us the change in momentum. The change in what? Final velocity minus initial velocity. Change in momentum is final momentum minus initial momentum. How do we get final momentum? Mass times final velocity. How do we get initial momentum? Mass times initial velocity. So we expanded this bracket. M times V is mv. M times U is mu. M times V gives you final momentum. M times U gives you initial momentum. And this is changing what? Momentum. So class, why am I because the question says per second. It suddenly hits by another body moving in the same direction, thereby changing the speed of the former body to 50 meters per second. What is the impulse received by the first body? Class, follow me now. I want to multiply this Newton's second law of motion. I'm going to have 4 time equal u. Force times time equals to m into bracket From secondary school, remember that impulse multiplied by time. Product m into bracket v minus u. Many students formula for impulse only mass into velocity. And this is the formula that will deal with this question. A body of mass 6 kg. So mass is 6 kg. Moving with a speed of 20 meters per second. Initial speed is 20 meters. U is 20 meters per second. It's suddenly by another body moving in direction. Thereby changing the speed of is now 50 meters per second. So 50, U is 20. So the impulse received by the first body is mass into bracket final velocity 50 minus initial velocity 20. I know it's very, very strange to be solving impulse without using first times time, because everybody knows that the popular formula for impulse is first times time. But this is another formula. So this is 6 20 will give you what? It will give you, and 80 kg meter per second. Because mass, therefore you have kg meter per second. So class, you could be asked to calculate without. So if you ask, so don't be so used to using only force and time to calculate impulse. You can also use mass, final velocity, initial velocity, and you get the impulse. You get the what? You get the impulse. Let me see if you are following me. So drop your comments. If you are lost anywhere, let me see your comments so I will know what to do. If you're following, good. We are 57 live now. Confusing. What's confusing? Just came in now. What are you guys studying? If you just came in now, do you know that if you are live, you can actually rewind the video a bit and check. Yes, you can. Yes, you can. Oh, thank you. 31 students like this video. Well done. Okay, someone says, sir, stop using the microphone. It's lagging. Someone says, sir, stop using the microphone. It's lagging. Okay, let me remove the microphone there. Let me remove Someone said it's lagging. Okay, I'm no longer using the microphone. Is it better? I'm no longer using the microphone. Is it better? Is it better? I've removed the microphone now. I'll solve again. Don't worry. I've removed the microphone now. Is it better now? Let me know. I'll solve again. Okay, someone said yes, it's better. Okay, good. Okay. I've removed the microphone, so we will not use the microphone. Don't worry. Since not everybody is hearing me, I'll solve again. If you are confused, I'll solve again. I'll solve again. Don't worry. I'll solve again. Thank you. 34 students have liked the video. Thank you. 35 students have liked. Thank you. Those that are clicking the like button, thank you. Yes. Someone says, sir, we understand. Someone says, okay, I will solve again. Don't worry. 36 students have liked so far. Thank you. 37 have hit the like button. I'll solve again now. I've removed the microphone. So if you were lost before, I'll solve again. No, let me go back to the board and solve again, please. Let me go back to the board and solve again. 38 people have liked the video. Thank you. Yes. Let's go back to the board. I'll solve again. Someone say, what of those that don't understand? I want to go and solve again. That's what I'm saying. I want to go and solve it again. So I'm cleaning the board now. And I want to solve again now. Yes. I want to solve again now. So they said, the formula you're going to use, class, please take notes. Newton's second law of motion, the mathematical formula for Newton's second law of motion is that the force is equals to mass into bracket final velocity minus initial velocity all over time. Force F is equals to mass into bracket final velocity V minus initial velocity U all over time. Please take note. Now, what is our mass? Our mass M is 6 kg. Our mass is 6 kg. Our mass is 6 kg. Now, before we do that, sorry, there's something I didn't do, sorry. Before we start solving, you must understand that you must, in order for this formula to be able to answer this question, you must first cross multiply so that F times T is impulse. F times T equals to M into bracket V minus U. F times T equals to M into bracket V minus U. And what's F times T? Impulse I. Impulse I. So I equals to M into bracket V minus U. And this is the formula that we're going to use to solve this question. This is the formula we use to solve this question. Because we are told that a body of mass 6 kg, moving with a speed of 20 meters per second. This is the initial speed. It was moving 20. U is 20 meters per. So mass is 6 kg. U is 20 meters per seconds. It suddenly hits by another body moving in the same direction. Thereby changing the speed of the former body to 50 meters per second. Thereby changing the speed of the former body V to 50 meters per second. What is the impulse received by the first body? So class, I'm just trying to explain to you that impulse is force times time, but impulse is also equals to N into bracket V minus U. Because obviously force and time is not given in this question. But impulse is also because F times T is I, so I is mv minus U. So we're going to say M, what's our M? 6. What's our V? 50. What's our U? 20. That will be 6 into bracket 50 minus 20 is 30. So that 6 times 30 is 180 kg meter per seconds. 180 kg meter per second. I hope this is better now. Let me see in the comment section. I can take the second question. Is this better? Will you hear me clearly? Hope you could hear me clearly. Is this better? Let me know in the comment section. Oh, thank you. We have 42 students have liked our live video. Thank you. Those that are hitting the like button, well done. Well done. Let me see your comments. Is this better now? Is it clear so I can go to the next question? Is this better so I can go to the next question? Okay, drop your comment. Someone say, yes, this is perfect. Amazing Grace say, yes, this is perfect. Thank you. Yes. Someone say, Daniel say, yes, it's okay. Daniel Joy said, yes, it's okay. Okay, Donna said, it's okay, sir. Yes. Okay, Favor said, yes, God bless you. Thank you. God bless you too. Those that are hitting the like button, thank you. If you are watching this video, you have not yet subscribed to our channel, hit the subscribe button. So, can we take the second question? Give me the go ahead. Can we take the second question? Give me the go ahead. Let me go and take the second question. Yes. Yes. Okay, let's go to the second question. Everybody's saying they understand now. Good. Okay. So let me clean this. Please make sure you are not allowing anything to distract you. Focus on the class. This is a serious class. So mute all your social media, mute all your TikTok. Put your phone on do not disturb. You're in a class. You've had the whole day to yourself. Just 1 or 2 hours to learn your book is not bad. You still go back to your TikTok after this class. Don't worry. But just learn very well. So mute all your social media. Put your phone on DND. Let us learn quickly. Okay, the second question. Time for the second question. Well done. Everybody still on live. I'm seeing 48 people live. They have not left. Good. Well done, everybody. Well done. Stay to the end of the class. Be serious with the class. Yes. Good. This is the second question. A particle of mass 0.4 kg. A particle of mass 0.4 kg is subjected to 2 forces in Newton. Is subjected to 2 forces in Newton. F1 equals 2I minus 4J and F2 equals minus 2.6I plus 5J. If the particle starts from rest, if the particle starts from rest at the origin, if the particle starts from rest at the origin, find its position and velocity. Okay, I gave this assignment yesterday. Can you drop your answer in the comment section? What did you get? Who are those that solved it? Let me see. What did you get as the answer? What did you get as the answer? It's an assignment. I forgot. So I should be seeing your correction, your solution first. What did you get as the assignment? What did you get as the assignment? Drop your answer in the comment section. What was the answer to this assignment? What was the answer to this assignment? A particle of mass 0.4 kg is subjected to two forces in Newton. Someone said it was difficult. Maxi said it was difficult. Okay. A particle of mass 0.4 kg. Who was able to solve this question? Who was able to solve this assignment? Thank you. Some people have liked more. We have 48 people have liked our live class. Well done, well done, well done. As you're watching, please hit the like button. Hit the like button. Well done, well done. A particle of mass 0.4 kg is subjected to two forces in Newton. F1 equals to 2I minus 4J. And F2 equals minus 2.6I. Virtue says I did not try to solve it. You left it. Okay. F2 equals to minus 2.6I plus 5J. If the particle starts from rest at the origin, find its position and velocity. Okay. This is what Clinton said. I just arrived. My goodness. Don't worry. You can still go and watch it again. Okay. A particle of mass 0.4 kg is subjected to two forces in Newton. F1 equals to 2I minus 4J. And F2 equals to minus 2.6I plus 5J. Okay, CMAV has solved it. He said S is 1.92. Okay, we'll find out. If the particle starts from rest at the origin, find its position and velocity. Well done. Those that are just joining the class, well done, well done, welcome. You are welcome, you are welcome. Okay, class, let's go and solve. Let's go and solve. We have more people that have joined. We have 58 people live with the class now. Well done, well done, well done. Those that have started with us and you're still there, well done, well done, well done. Now, let's go. Let us go and solve. Class, this question links dynamics with vector. So this is a two-topic question. Dynamic with what? With vector. So class, a particle of mass 0.4 kg. The mass is 0.4 kg. It's subjected to two forces. F1 is 2I minus 4J. And F2 is minus 2.6I plus 5J. Now let me give you first information you should know. Anytime a body is subjected to two forces. Class, yesterday we did a class, we did questions whereby we have two forces, right? We did when they are opposing and when they are complementary. We also did when they are right angle to each other. But class, someone you did not ask, there's a question you're supposed to have asked me. What are you supposed to have asked me? Sir, what if they did not mention whether it's complementary or opposing? Like, look at this question and they said the particle is subjected to two forces. They did not say it is complementary, they did not say it is what? Opposing each other. Because if they don't say it, how do you know whether you should add? Because I told you yesterday that if the forces are complementary, you should add, right? And if the forces are opposing, you should do what? Subtract. But when they don't mention complementary or opposing, what do you do? Now let me inform you that anytime they give it to a body subjected to two forces, your natural default mode, and they did not mention complementary or opposing, you must assume that it is complementary, class. Because class, it is difficult not to mention that the two forces are opposing. It's difficult. If they are opposing, it will be clearly mentioned. So the person that is easier not to mention is complementary, because yes, there are two forces acting on the body. So what they just mean is that these two forces are acting on the body, and obviously they are acting with the same interest in mind. Are we together? If the interest was not aligned, class, it would have been clearly mentioned. What's the implication of that? It means that if we have now understood that these two forces are complementary, we can now find the net force. First of all, but net force, don't forget net force when two forces are complementary is to add the forces up. Those that were in the class yesterday, you understand what I'm talking about, right? Add the two forces together to get the net force. F1 plus F2 give you the net force. This is 2I minus 2.6I will give you minus 0.6I and minus 4J plus 5J. Minus 4J plus 5J will give you plus 1J because minus 4 plus 5 is plus 1J. So our net force is minus 0.6 on the I-axis and 1 on the on the I-axis and 1 on the J-axis. Don't forget, when we did vectors, if you missed our class on vector, we'll probably do another class on vector in this live class, don't worry. Excuse me, I'll teach vector again, don't worry. But remember that when I taught vector back then, even last year before we went on break, I taught vector. I said I represents the x-axis, J represents the y-axis. I represents the x-axis, J represents the y-axis. Are we together? So it means that the force of this body, net force on this body, is minus 0.6 Newton on the x-axis and 1 Newton on the y-axis. The mass, that this force acted on a body of mass, 0.4 kg. Let's go back to the question. So class, one thing we have done is we have resolved the two forces, because anytime they give you a question that has 1, 2 or 3 more than two forces, you first thing you need to do before you even start solving, resolve the forces. Ask yourself, am I adding up? Am I subtracting? Are they at right angle to each other? Like yesterday, we gave you forces that at 90 degrees to each other. We now have to find using Pythagoras theorem, right? If you missed that video, go and watch it. I posted a link on our group chat. Go and watch it so you can follow up. Now, class, let's go back to the question. So we have resolved these forces by adding them together. What made us add them together? Because we've now said they are complementary, since they did not mention that they are opposing. Now, a particle of mass 0.4 kg is subjected to two forces in Newton, F1 and F2. If the particle starts from rest, it means that if start from rest, that U is 0. I'm trying to collate all my parameters that as much as possible so that I can have a better chance of solving the question. If the particle starts from rest at the origin, find its position and velocity. Class, position means displacement. Position means what? Displacement. Anytime they say position, means displacement of the body. Why they use the word position is they were dealing with vectors. So the body's displacement has direction. You understand? Displacement, position, and velocity. Class, we have the mass and we have the net force. We need the position and velocity. But before we get the position and velocity, let us go and get the acceleration. Class, we know that for a net force is always equals to mass multiplied by acceleration. Net force equals to mass times acceleration. Do you remember that? F is m times a. We're going to make a solid on the formula. To make a solid on the formula, this will imply that a equals to net force all over mass, right? Force all over what? All over the mass. What is our force? 0.6I plus 1J. All over, what's our mass? 0.4. What are we looking for? Our acceleration. Did they ask us to find acceleration? No. They said we should find position and velocity. But we can never get these two without getting acceleration first. We must get acceleration first. Because we have force and you have mass. Why not easily get acceleration? Because force is mass times get acceleration. So we don't need to use these two forces they gave us again. You know why, right? We have resolved these two forces to this. These two forces have been resolved to give this. So this is our main force now. We have no business with these two guys again. This is our net force. So net force equals to mass times acceleration. We don't know the acceleration. So we'll make acceleration straight of the formula. Acceleration is net force divided by mass, which is net force is 0.6I plus 1J divided by 0.4. How do we divide I and J all over 0.4? That will be the next problem, right? Now follow me. We're going to say net force will be equal to, class, this 0.4 belongs to both 0.6 and 1. We can split it. This same expression can be written as 0.6I all over 0.4 plus 1J all over 0.4. 0.6I all over 0.4 plus 1J all over 0.4. And we're going to calculate. My calculator, where's my calculator? 1 minute, let me get my calculator quickly. My calculator. I hope we are still there. Let me get my calculator. Drop your comments. Let me get my calculator. Quickly up from my bag. Okay, I'm back. I hope no one has left, oh. For some of you, any small excuse just to not be serious. Okay, good. Okay, my calculator is not close by, so I have to continue. Okay, yeah, someone is pointing at minus 0.6. So minus 0.6. So what is minus 0.6 divided by 0.4? Someone should help me. My calculator is not close by. But let me try using my head. Minus 0.6 divided by 0.4 looks like, you do this, that's 6 over 10 divided by 4 over 10. Multiply this, you have 10 over 4. 2 here 3, 2 here 2. Looks like minus 1.5i. Minus 1.5i plus 1 divided by 0.4 looks like 2.5j. 1 divided by 4 over 10. 1 times 10 over 4. This is 5. Yes, 2.5j. Yeah, so we have minus 1.5i plus 2.5j. That is the acceleration. Please, let me confirm in the comment section. Am I correct with the calculation? My calculator is not close by. Am I correct with the calculation? Minus 1.5i plus 2.5j. So the minus 0.6 divided by 0.4 is 1.5, right? Is correct? Yes. My calculator is not close by, and 1 divided by 0.4 is 2.5, correct? So I can go ahead. Okay. So class, let's go ahead. Now, this is the acceleration. So class, I'm going to split this as this acceleration occurs both on the I and the J components. So my acceleration on the I component means my x. I means x-axis, don't forget. Anytime you have I means x and J means y. Class, vectors are represented in I-axis vectors represents the x-axis. J represents the y-axis. So I is x, J is y. So it means that if my acceleration is minus 1.5i plus 2.5j, it means that my acceleration on the x-axis is minus 1.5i. And my acceleration on the y-axis is 2.5j. My acceleration on the x-axis is minus 1.5i, and my acceleration on the y-axis is 2.5j. What will I do with that information? Don't forget, I'm looking for displacement, I'm looking for velocity. We're now going to ask ourselves, which one is the easiest one to get? Class, let us bring our equation of motion. V equals to U plus AT. V equals to U plus AT. V equals to U plus AT. We have V squared equals to U squared plus 2AS. We have S equals to UT plus half AT squared. Class, I think I can easily use this. I can easily use this to get my S. Although I don't have time. There's no time given here. Okay, what we can do, the body starts from rest. U is 0. The body starts from rest means my U is 0. If my U is 0, and I have my A, do I have my time? No. I don't have my time. You have your V squared equals to U squared. My U is 0. I have my A, I have my S. Okay? So we're going to say, class, don't forget that velocity equals to acceleration is velocity all over time. Acceleration is velocity all over time. I think there's something they didn't give us in this question. Let's see. Class. They say velocity at t equals 1.6 seconds. They say find its position and velocity at t equals 1.6 seconds. Class, did I mention 1.6 seconds yesterday? Did I give 1.6 seconds yesterday, class? Let not be that I made it difficult for you. Did I mention 1.6 seconds yesterday? At t equals 1.6 seconds. Did I mention 1.6 seconds yesterday? Okay, I did. Maxi said I did. Franklin said I did. Yes. Okay. Okay. So I mentioned 1.6 seconds yesterday, right, in the question. Good. Good. Everybody saying yes. Good. Well done. This is good to know that everybody is still active in the class. Good. Good. Okay, let's go ahead. So that's what was causing the confusion. So we have time. If we have the time 1.6 seconds, then there's no cause for alarm. Class, it means that I can use this first one to easily get my V. You can looking for velocity, final velocity V. My initial velocity U is 0 because the body starts from rest, so U is 0. So U is 0. So I'm going to say that my V equals to U is 0, right? Plus AT. But class, my acceleration, I have two acceleration. Acceleration on the x-axis and acceleration on the y. It means I'm going to have two velocity. Velocity on the x-axis, I'm going to use acceleration on the x-axis. Velocity on the y-axis, I'm going to use acceleration on the y-axis. Of course, time does not have x and y-axis, so time is time. Time is time. It's now time for, permit me to clean the question. We already have the question in our book. Permit me to clean the question. We are looking for position and velocity at t equals 1.6 seconds, right? So part of our parameter we should have written here is t equals to 1.6 seconds. Thank God you confirmed that I gave it yesterday. I mentioned 1.6 seconds yesterday. How I did not include it today now is, I'm still very surprised. So class, t is 1.6 seconds. So I'm going to say v. Remember we're looking for position and velocity. We're looking for position and what? Velocity. Let's find velocity first. V equals to u plus at. V is what we're looking for. U is 0 because it starts from rest. A, we have two A's. We have A on the x-axis and A on the y-axis. So we're going to have V on the x-axis equals to 0 plus A on the x-axis time. V on the y-axis 0 plus A on the y-axis time. So we're now going to have, if this 0 and 0, it means that Vx is equals to Ax times time. What's Ax? Our Ax is minus 1.5 I. And what's our time? Our time is 1.6 seconds. We have an answer here. Our Vy is Ay times time. So it only makes sense that the acceleration on the x-axis should be used to get the velocity on the x-axis. And acceleration on the y-axis should be used to get velocity on the y. What is our Ay? Our Ay is 2.5 joules. That's 2.5 joules multiplied by 1.6 seconds. We're going to have velocity on the y-axis. Someone should help us with the calculation. I don't have my calculator here. Someone should help us with the calculation quickly. One of them looks like 3.2, but I'm not sure. One of them looks like 4. I don't know, but no, not 3, not 4. I'm thinking 3.2 somewhere. But help me. What is Vx and what is Vy? Please, punch your calculator there. What is Vx and what is Vy? Vx is 2.4. Thank you, Megan. 2.4 I. Minus 2.4 I, right? On the x-axis. Thank you, Victor. Thank you, Messi Bamidele. Minus means you are still following. Minus 2.4 I, right? Thank you. So they say Vx is minus 2.4 I. What is Vy? What is Vy? Vy is 4 joules. Vy is 4 joules, okay. Vy is 4, sorry, did I say joules? 4J, sorry, 4J. Why am I saying joules? 4J. So class, we've gotten the velocity on the x-axis and velocity on the y-axis. How do you report it? How do you represent it? You now say V is equal to minus 2.4 I plus 4J meter per seconds. Minus 2.4 I plus 4J meter per seconds. Minus 2.4 I plus 4J meter per seconds. That will be your V. Now it's time to get our displacement. Please, is there any confusion anywhere? Let me see your comment. Is anybody lost? Before I go further and further again. Okay, Michael said 100. Good. Means you are following. Please, if you are lost, let us know. 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 Okay, bet you said no, sir. That means you are following, right? Nobody's lost. Is anybody lost anywhere? Solomon said yes. It means you are lost. Okay, someone said, Joy said, I'm lost from the beginning. Did you join late? Clinton said, yes. Solomon said, I'm lost. Okay, what we'll do, let me finish the whole question, then I'll come again from the beginning for everybody at once. Do you get? Okay, Solomon said I'm lost. Let me finish the question and I'll come again from the beginning. Those that are liking the live video, thank you. Those that hit we have 52 people that have hit the like button. Thank you. I will come again from the beginning. Let me finish the live video. Joy Wisdom said, but I've been trying to notify you from the beginning. Okay, I will come again from the beginning. Don't worry. Just stay tuned there. Let me finish the whole question. I will solve from the beginning. Are we together? Solomon Oyin said, this is my first time. You are welcome. That means you missed yesterday's class. That's why you are lost. I posted the link to the class on our group chat. I will personally send you the link again after today so you can have the link. I think if you follow from the last class, you get it. But I will explain today's class again. Let me finish the question completely. So we have gotten Vx and Vy. It's now time to get S, the displacement, position. We're going to use this to get S. This U is 0 because U is 0. U is what? 0. So 0t means 0. So this can go. Everybody has what? 0. 0 times t is 0. 0 times t is 0. 0 times t. They just took our light now. I hope you are still seeing the board. S equals to 1 over 2 at squared. We're going to use S equals to 1 over 2 at squared because U is 0. U is what? 0. U is 0. Can we still see the board? I just took my light now. But one of my solar lights came on. I hope you can see the board, class. Although I'm seeing the board from my screen. I hope you can see the board. I hope you can see the board. They just took my light now, but there's a solar backup that came up. Small, but it's not that bright like the normal lights. You can see the board. Okay, let's continue. Let's continue. Let's continue. Good, good, good. Let's continue. Okay. So S equals to half at squared. But our A occurs on the X and the Y axis. So our S will also occur on the X axis. When you're using S on the X axis, you use acceleration on the X axis. And we're going to use S, find S on the Y axis too. Half AYT squared. When finding the position on the Y axis, we use acceleration on the Y axis. When finding position on the X axis, we use acceleration on the X axis. So let's proceed. Don't forget, in case you are lost, I'll come again. In case you are lost, I'll come again. So we're going to say 1 over 2. What is A on the X axis? Minus 1.5i. That's times minus 1.5i times t squared. What's our t? 1.6, right? Times 1.6 all square. Times 1.6 all square. Our S on the Y axis, 1 over 2. What is A on the Y axis? 2.5j, right? 2.5j times t squared, which is 1.6 all square. Don't forget, if you are lost, I'll come again. Remember that, I'll come again. We're almost done, so I'll start it again and come again. So everything will be very clear. Someone should help us with the maths for this and this. What's the final answer? I'm on my calculator. So what's S on the X axis? And what's S on the Y? After doing the math, someone should do the math for us. What will you have? Drop your comment, drop your comment. What's the answer? What's the position on the X axis? What's S on the X axis? And what's S on the Y axis? Thank you. Those that are hitting the like button, thank you. We have 53 likes. 53 likes. That's very good. We have 50 people are live, but we have more likes than even people that are live now. Please, what's the answer on the S axis? S on the S axis. Okay, Bamidele Messi, thank you. Minus 1.92. Minus 1.92, yes. On the X axis, minus 1.92 I. What of the Y axis? What of the Y axis? What of the Y axis? What's the S on the Y axis? What's S on the Y axis? Thank you. Those that are following, thank you. Well done. Well done. Those that are hitting the like button, well done. S on the Y axis 3.2J. We have 54 likes on the like button. Well done, well done. 3.2J on the Y axis, right? So 3.2J on the Y axis. So it means that our position S is minus 1.92I plus 3.2J meter. This is our position, minus 1.92I plus 3.2J meter. This is the position, and this is the velocity. We'll just answer the two questions now. We'll just answer the two questions on position and velocity. It's now time to come again. For those that are lost, it's time to come again. So if you are lost, pay attention now. This is your time. This is your time. Pay attention, pay attention, pay attention. Pay attention. We are coming again now. We are coming again. So let me clean the board and start again now. Then we'll proceed from there. So So let me start clearing for me in case those that are still writing there. So we are coming again. So we are told that a body of mass 0.4 kg. Please follow carefully, follow carefully. Those that were lost, follow carefully, follow carefully. I'm coming again now. Follow carefully, follow carefully. Those that were lost before, I'm coming again. If you notice, I erased every other thing apart from the parameters. A body of mass 0.4 kg was acted upon by two forces, F1 2i minus 4j and F2 minus 2.6i plus 5j. So if the body was initially at rest, u is 0. What is the velocity and position? So they're asking us for the position and velocity. Position means displacement, s means displacement, and velocity at t equals 1.6 seconds. So to find the position, I said I say find position, it means displacement, it means displacement. Find the position and velocity at t equals 1.6 seconds. Find the position and velocity at t equals 1.6 seconds. Find the position and velocity at t equals 1.6 seconds. So let us find the position and velocity at t equals 1.6 seconds. So to do that, first of all, the body was acted upon by two forces, right? F1 and F2. Anytime you are told that a body was acted upon by two forces, you are supposed to add up the two forces together. But if they told you that a body was acted upon by two opposing forces, if the two forces are opposing each other, you're going to subtract the smaller force from the bigger force. So the bigger force minus smaller force to get the net force. But class, if they don't mention that the two forces were opposing, you are supposed to add up the two forces, F1 plus F2, add them together. Our F1 is 2i minus 4j, our F2 is minus 2.6i plus 5j. So that our net force will be minus, if you do this math very well, 2 plus minus 2.6i. Plus times minus is minus. So this minus will supersede this plus, because plus times minus is minus. So that will be 2i minus 2.6i. Remember that when you're adding up vectors, I to I, j to j, remember? So 2i minus 2.6i will give you minus 0.6i. You can confirm in your calculator. 2 minus 2.6. 2 minus 2.6 will give you minus 0.6. 2 minus 2.6 will give you minus 0.6i, because this is the I part, right? Now the j part, minus 4j plus times plus is still plus. So minus 4j plus 5j. Minus 4 plus 5 is plus 1. Minus 4 plus 5 is plus 1. So our net force, you must get the net force. The net force is minus 0.6i plus 1j. You're not going to recall that net force is mass times acceleration. Net force, the net force acting on a body, let's start solving from here. The net force acting on a body is the mass times the acceleration. Let us make acceleration sorry for the formula. It means our net force, our acceleration will be net force divided by mass. Because divide both sides by mass, mass cancels mass, so the acceleration is net force divided by mass. Now, what's our net force? Our net force is minus 0.6i. Look at our net force here. Net force is what you get after resolving the two forces that are acting on the body. The net force is what you get after resolving the two forces that are acting on the body. Minus 0.6i plus 1j divided by the mass. What's the mass? 0.4 kg. The mass is 0.4 kg. Now do you resolve this? This 0.4 is a common denominator to both minus 0.6i and 1j. So let us split it. This means that is minus 0.6i all over 0.4 plus 1j all over 0.4 minus 0.6i all over 0.4 plus 1j all over 0.4. This 0.4 belongs to both this guy and this guy, so we split it. Now minus 0.6i divided by 0.4, we have minus 1.5i, and 1 divided by 0.4, we have plus 2.5j, I think. This is therefore became the net force. Sorry, not the acceleration, sorry, the acceleration is what we are solving. Acceleration. We now have told ourselves that this I represents the x-axis, this j represents the y. So it means that our a on the x-axis is minus 1.5i, and our a on the y-axis is 2.5j. Our a on the x-axis is minus 1.5i, our a on the y-axis is 2.5j. So we're now going to say, they say we should find the position and velocity. Don't forget that t equals to 1.6 seconds. To get the velocity, we're going to say v equals to u plus at, the first equation of motion. Everybody knows this equation. But since we have acceleration on the x-axis, acceleration on the y-axis, we're also going to have velocity on the x-axis and velocity on the y-axis. For velocity on the x-axis, we're going to use acceleration on the x-axis, this. And for velocity on the y-axis, use acceleration on the y-axis, this. Which is, so vy is u plus ayt. But u is 0, remember, u is what? 0. So this is just vx equals to ax times t. Ax times what? T. Who is ax? Minus 1.5i. Multiplied by t. Who is t? 1.6 seconds, right? T is 1.6. Same thing, vy. Ay, which is ay? 2.5j. Multiplied by t, 1.6 seconds. So that your Vx, we said 1.5 times 1.6 was what again? What did we get that time? I've forgotten. We got that 2.4, something like that. 2.4 I, and Vx and Vy, we got, I think, 4j. Please, is this correct? Is this correct? Vx and Vy, this is what we got. Vx and Vy. Vx and Vy. Okay, our Vx was carrying minus 1.5i. Our Ax, sorry. Our Ax is minus 1.5i, so that's minus 2.4i. Minus 1.5i times 1.6 is minus 2.4i. And our Vy is 4j. If my memory is still correct from what we got. So now you now say, so total velocity V is, mention the I-axis, so minus 2.4i plus 4j meter per seconds. Meter per seconds. It's now time to do the position. The position, the same thing. We're going to get S equals to ut plus half at squared for the position. That's displacement. Position means displacement. Position means what? Displacement. This S stands for displacement. But u is 0, so 0 times t is 0. So I'm just dealing with S equals to half at squared. S equals to half at squared. We're going to have S on the x-axis. I'm going to use acceleration on the x-axis. To get S on the y-axis, use acceleration on the y-axis. So we're going to say 1 over 2. What is A on the x-axis? Acceleration on the x-axis is minus 1.5i. That's minus 1.5i times t squared. Who is t? 1.6. 1.6 all square. And acceleration on the y-axis, we're going to use acceleration on the y-axis 1 over 2. What's acceleration on the y-axis? 2.5j. 2.5j times 1.6 square. So we're now going to have position on the x-axis and position on the y-axis. What did we get on position on the x-axis again? 1.5 times 1.6. What did we have? What did we have? What did we have? Quickly, someone should help us. Square, we have 1.92, right? So we had minus 1.92i. And we had, what do we have on the other side? 3.2j. So that our total displacement S is minus 1.92i plus 3.2j meters. minus 1.92I plus 3.2J meters. Class, are we following? Are we correct on the S and the V? This is what we got before. It is what we got before. It is what we got before. It is what we got before. I hope we are still there. I wish we are still there. Please drop a comment. Drop a comment. Drop a comment. Let's know that we are still together. Are we still together? Are we still together? Yes. Virtue Great said yes, sir. Yes. Well done. Well done. Well done. Well done. Virtue Great said active, sir. Yes. 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 Mercy Bamdele said yes. Ikechuku Joseph said no. Are you just joining? Joseph said no. Koreb said yes. Donald said yes. Victor said yes. Solomon said, Onyi said, you talk very fast, sir. Okay, this was the second time I'm taking this. This was the second time I'm taking this. Is position the same thing with displacement? Yes. Position and displacement are the same thing. Yes. Position and displacement are the same thing. Yes. Yes. Position and with displacement. Yes. 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 Okay, it's time to take the Newton's third law of motion. Remember that we are still under dynamics. We started with first law, then second law. Now this is third law. This is third law. I think someone just gave me a gift. Thank you. I'm seeing 400 naira. I don't know what it means in YouTube. Thank you, Maxi. I think it's Maxi. Thank you, Maxi. Maxi. I'm saying 400 something. I don't know whether it's a gift system on YouTube. YouTube just notified me now. Thank you. Thank you. It shows that you're following the class and you appreciate what we are doing. Thank you very much. Okay, let's go to Newton's third law of motion under dynamics. Someone said, how did we get 1.92? How did we get 1.92? It is, we use this 1 over 2, do your math, 1 over 2 times minus 1.5 times 1.6 square. 1 over 2 times minus 1.5 times 1.6 square should give you 1.9 minus 1.9 to do your math very well. Do your math very well. Do your math very well. Yes, 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 yes. Yes, 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 yes. So let's go to Newton's third law of motion now. I know it's looking very, it's simple, right? Action and reaction, but you see questions under it and you follow up too. You see that, see what Newton's second law of motion, this question that we're doing on the board now is these first two laws of motion that brought it out. Now let's go to the third law now. Third law of motion, third law of motion. Let's go, let's go, let's go. Make sure you're still with me, make sure you're still with me. Make sure you're still with me. Don't forget, if you are lost, you can always replay the video. The guy that said I'm too fast, you can replay the video, you can slow it down. There's all those things are in YouTube. You just rewind a bit. Okay, good luck, son. They say yes, it's a gift. Okay, I didn't even know. So someone can give someone on YouTube like this. Thank you, thank you. Whoever gifted me this 400 naira. Thank you, thank you. I appreciate. Thank you. So you can even just gift someone on as you are watching the person. This is good. Thank you, thank you, thank you. Now. So please write down Newton's third law of motion. Third law of motion. Newton's 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 third law of motion. States that, let's go. Newton's third law of motion states that for every action, there's an equal and opposite reaction. For every action, Newton's third law of motion. Newton's third law of motion. For every action, there's an equal and opposite reaction. For every action, there's an equal and opposite reaction. For every action, there's an equal and opposite reaction. That's action and reaction are equal but opposite. Now, what does this third law mean? Action is talking about force. So action means applied force. Action means what? Applied force. While reaction means responding force. Responding force. Class, there cannot be responding force without applied force. When you apply force, the body has the right to also respond. Are we together? When you apply force on a body, the body also has what? The right to do what? To respond. So we have action and reaction are equal, but they're opposite. This cannot be better explained than the best way to explain this is to come and explain the dynamic between the weight of a body acting downward and the reaction force acting upward. Don't forget that the weight of a body is also called force. Weight is also force. The weight acting on a body is also called what? Force of gravity acting on the body. Weight is also called what? Force of gravity. So weight is force. Class, are you aware that if a body is on the ground and it is weighing 80 Newton, because the weight is measured in Newton, not kg. It is mass that is measured in kg. Weight is measured in Newton. The relationship between weight and mass is that weight is equal to mass times acceleration due to gravity. So weight is mass times acceleration. That's why weight is a force. Because what's the formula for force, class? Force is mass times acceleration. And weight is also mass times acceleration. But this one is acceleration due to gravity. So both weight and force are what? Forces. Force is mass times acceleration. Weight is also mass times acceleration. But acceleration due to, that's why they have the same unit. They have the same what? Unit. But to my point, that's not my main point. My main point is this. If this body is 80 Newton, class, for this body to be in equilibrium, the ground must also provide an 80 Newton force, reaction force, but in opposite direction. So this action, 80 Newton, opposite reaction, 80 Newton. They are equal, 80 are equal, but they are opposite direction. Direction is opposite. That's what they mean by action and reaction are equal but opposite. That's what we mean by action and reaction are equal but opposite. A body weighing 80 Newton, acting downward, because the weight of a body always acts downward. While the reaction force, also known as the normal force, another name for reaction force is normal force, acts upward. The reaction force acts upward, the weight of the body acts downward. Class, the weight of this body and the reaction force on the ground must be the same for what stability to be established or for equilibrium to be established. If one weight is bigger than the other, class, the body will either go up or come down. If this weight is bigger than 80, this body will be pushed up. If this 80 is bigger than this one will come down. But for there to be stability, neither going up nor down, this action force and reaction force must be equal but what? Opposite. If you're standing, as I'm standing on the ground now, why I'm able to stand on the ground without sinking down is that the ground is able to provide a reliable reaction force to the weight, my weight. That's why there's a balance. If my weight is higher than this ground's force, my weight will overcome the force of the ground and I will go down. Because my weight is bigger, I will go down. Have you ever tried to stand on something that is not that you're heavier than? You overcome it and you go down, right? Because your weight is higher than that stuff. But the ground is providing a reaction force that is commensurate with my weight. That's why there's equilibrium. That's why there's equilibrium. Class. One key aspect of the Newton's third law of motion is the elevator lift system. Please write down the elevator lift system. Let us look at the elevator lift system. It's a key application of the Newton's third law of motion. Please, I hope we are still together. Let's look at the elevator lift system. Please, everybody drop a comment. Yes, you know, this is an online class. We have to stimulate you so that, because you don't know who is sleeping, who is pressing on the phone. Please drop a comment. Let's know that we are still together. Everybody drop a comment. Everybody drop a comment. If you're on this live class, your attendance is needed. Drop a comment. Everybody drop a comment. Megan, active. Virtue, active. Yes. Drop a comment, please. Drop a comment. Active, yeah. Richard, well done. Uzoma Michael, well done. Very active. I like this. Koreb, active, yes. Nobles, Enoch, active. Frank, active. Yes. Success, active. Van Ansom, active. Messi, Bamidele, active. Well done. Frank, active. Maxi, active. Osadebe, active. Frank Victor, active. Adizwa Clinton, active. Joy Wilson, active. Well done. Active. We are with you, sir. Ikechuku, yes. Well done. This is good. This is encouraging. Yes. So I'm not just alone. Yeah, this is good. So let us write down the elevator lift system. Elevator lift system. the elevator lift system, so elevator slash lift, is a very important aspect of Newton's third law of motion. Because class, have you ever been in an elevator before, in a lift? There are two things that happen. There are two different experiences you have. When the elevator is going down and when the elevator is going up, how do you feel? Class, when a lift is coming down, when the lift is coming what? Down. And when it is going up, the experience is different, class. Have you noticed that when you're in an elevator lift system and the lift is coming down, you always feel as if, at a point, you feel as if you're falling. You feel lighter when coming down. When going up, you feel heavier. There's a reason why. There's a reason why. I'll explain. It's Newton's third law of motion. Are you aware that there are three forces at play in the elevator lift system? There are three forces at play in the elevator lift system. Number one, we have the weight of the body. The weight of the body in the elevator lift system. Weight of the body in the elevator lift system, W. Weight is W. Two, we have the apparent weights. The apparent weights or tension in the lift system. The apparent weight or what? Tension in the lift system, we call it C. And the last one is we have what? The resultant force. The resultant force, F, R. These are the three forces at play in the lift system. The resultant force is also called the net force. The resultant force is also called the net force. So there are three forces at play in a lift or elevator system. The weight of the body, of course, you are inside the elevator, so you have your weight, right? The apparent weight or tension in the lift, class. The apparent weight or tension in the lift is the weight that the lift system has to produce to either take you up or to bring you down. The weight or the force that the lift system has to produce to bring you down or take you up. Don't forget, when it's bringing you down, it's bringing you in favor of gravity. When it's taking you up, it's taking you against gravity. Now, class, the resultant force is the resolution of these other two forces, class. Class, let me tell you something. If you have to calculate the resultant or net force, it's also called the net force. The net force in the lift system, the formula, there are two formulas. When the lift system is coming down, it means something. For the lift system to be coming down, it means that the weight of the body is bigger than the weight in the lift system. That's why the body can come down. So class, anytime a lift is going down, the lift or the elevator system has to adjust to make sure that the apparent weight in the lift is lower than the weight of the body inside the lift. Follow me again. The elevator lift system has to adjust in such a way that the apparent weight, also called the tension in the lift system, must be lower than the weight of the body. Class, if the body is weighing 500 Newton, don't forget, weight is measured in Newton. Most of us are used to measuring it as kilogram, it's Newton. If the body is weighing 500 Newton, that body can never come down if the elevator system is giving it 600 Newton. Because class, there is nowhere in the world that 500 Newton will overcome 600 Newton and to come down. So for this body to come down, the elevator lift system must produce a force that is lesser than 500 to allow this body to easily overcome it and come down. Maybe 300 Newton. That's when the lift is going down. So when the lift is going down, it means that the weight of the body in the lift system is bigger than the tension or the apparent weight in the lift system. When the body is going down, you can note it down. When the body is going down, the weight of the body inside the lift system is greater than the tension or the apparent weight. Another name for tension is the apparent weight or tension in the lift system. The weight of your body must be bigger than the tension in the lift system to allow you to overcome it and come down. When the body is going up, class, for a body to go up, class, if the body is weighing 500 Newton, if this tension in the system is 300 Newton, class, 300 Newton cannot push 500 Newton up. 300 Newton cannot push 500 Newton up. What does that mean? It means that for this body to go up, The elevator must adjust and produce a weight that is bigger than 500, at least 600 or more. So that 600 can push 500 up. So then what that means that when the lift is going up, the tension in the lift is greater than the weight. Please note, when the lift is coming down, the weight is greater than of the body, the weight of the body inside the lift, the weight of the body inside the lift, the weight. That means I said I'm talking fast. Let me slow down. The weight of the body inside the lift system, that is, you're inside the lift, right? Your own weight is bigger than the tension in the lift system. When the body is coming down, when the lift is coming, when the lift is coming down, when the lift is coming what? When the lift is going up, the tension in the lift is greater than the weight. What does this mean? Don't forget to calculate the net force or resultant force. I told you there are three forces, right? The weight of the body, the apparent weight or tension T, and the resultant force, also known as the net force. Don't forget that net force is always bigger force minus lesser force. Net force is always bigger force minus lesser force. So we're going to have two formulas for net force, class. We're going to have formula for net force when the body is going down, and formula for net force when the body is going up. When the lift is going up. Sorry, not the body. The body is inside the lift. So the lift is going up or lift is coming down. We're looking at the elevator or lift system. Class, when the lift is coming down, the net force is the bigger force minus the lesser force. Who is the bigger force when the lift is coming down? The weight, W. So W minus T is the formula for net force when the lift system is coming down. What's the formula for net force when the lift system is going up? Who is the bigger force time around? T is greater than W, right? So T minus W. Please take notes. When the body is coming down, the net force is weight minus the tension. When the body is when the lift is coming down, the net force is the weight, because when coming down, the weight is bigger than the tension. Don't forget, for you to find net force, is usually bigger force minus smaller force. Bigger force minus smaller force. Net force is the bigger force minus the smaller force. So when coming down, the bigger force is the weight. That's why it's weight minus T. When going up, the bigger force is the T. And I'll explain why this is bigger when it's going down and why this is bigger when it's coming up. You can always replay the video and watch again. That's why we have two formulas. But don't forget, class, I want to remind you that net force, previously in Newton's first law of motion, net force is mass times acceleration. In Newton's first law of motion, net force is mass times acceleration. So class, it means that net force when coming down is MA equals to W. What's W? Mass times acceleration due to W is mg. Remember, W is mg. I'm looking at this formula. That is F. Net force is mass times acceleration. W is mg minus T. Minus what? T. So let us bring minus T to this side. Don't forget, we're looking at when it's coming down. We'll still look at when it's going up. When it's coming down, our net force is mass times acceleration. W is mg minus T when coming down. Class, we're going to bring minus T to this side and bring MA to this side. So minus T coming to this side becomes plus T. Equals to this, already mg here. When MA moves to this side, what does it become? Minus MA. I'm just deriving the formula now. This T is the most popular question asked in the lift system. They usually ask, what's the tension or apparent weight in the lift system when the lift is coming down or when the lift is going up? Class, the two formulas are different. The apparent weight or tension in the lift system when the lift is coming down is different from the apparent weight or tension in the lift when the lift is going up. So when the lift is coming down, don't forget this is still down. So we're using this. F net force is mass times acceleration. W is mg minus T. Bring minus T to this side becomes plus T, because the sign will change from minus to plus. MA moves to this side become minus MA. This M, factorize M out. T equals to, bring out M into bracket G minus A. Factorize M out, here class. This is the formula for the tension in the lift system that is coming down, when the lift is coming down. Now let us do the one for when the lift is going up. What happens when the lift is going up? What happens when the lift is going up? I hope you are still with me. It's important I ask, because this one at midnight. Let me not be talking to myself here. Please drop a comment again. Please drop a comment again. It's not easy to just be standing here in the night like this. Drop a comment again. Let me be sure that you are there. Are we still there? Yes, drop a comment. Thank you. Those people have liked the video. 57 likes on this live class so far. Well done. Virtue says, sir, sleep is in my eye. Well done. At least, thank you for being honest. This one say I'm active. Correct said I'm active. Go ahead, sir. Yes, we are here. Mazi said we are here. Well done. Ikechuku said hi. Yes, yes. Well done, class. Well done. Active. Michael said active. Osadibi said active. Yes, yes. Yeah, well done. Oh, yeah, let me go and do the second one. So you're following the class, right? Thank God nobody has said they don't understand. So you're following. Good, good. Let's do the second one. When the lift is, this one is what? When the lift is coming down. When the lift is going up, class, our net force system mass and acceleration equals to T, we don't know who is T, minus W is W, W is mg. W is mg, so T minus mg. T minus what? Mg. Let us bring minus mg to this side because plus mg. So we're going to have plus mg plus, there's already ma here, right? Plus ma equals to T, right? So T is mg, T is mg plus ma. Again, we have m occurring there here. What do we do? Factorize it out. So T equals to m into bracket g plus a. Class, this is the tension in the lift system when the lift is going up against gravity. This is the formula for tension in the lift system. When it's going up, we use plus. When it's going down, we use minus. The difference between this formula and this formula, they both have T, T, M, M, G, G, A, A. Just that one is minus and one is what? Plus. So the formula for a tension or apparent weight in the lift system, don't forget, what is the apparent weight or tension in the lift system? It is the force weight that the lift must produce to be able to overcome the weight of the body in the lift system, either when going up or when coming down. Another name for apparent weight or tension is what? Is tension. Another name for apparent weight is what? Tension. Now, class, don't worry, I'll soon round up. For those that are feeling sleepy, I'll soon round up. I'll just give a question. I will come and continue tomorrow. Now, class, so the general formula for tension in this system is T equals to M into bracket G plus or minus A. T equals to M into bracket G plus or minus A. T equals to M into bracket G. So if I want to combine these two formulas, I will say T equals to M into bracket G plus or minus. Because the difference between this and this is just plus and minus. So put the plus or. But we all know that the minus is used when the body is coming down and plus is used when it's going up. Please don't confuse this. Very, very important. Very, very important. Let us take a question that we'll come and continue with tomorrow, when we come tomorrow. This question is what we use to continue what? Tomorrow. Take this question down quickly. It's a popularly asked question in the exam. I will write the question, I'll also dictate it. Let's end with this question. Are we ready? It's a popularly asked question. I've seen this question in past question. For a big lump of meat. A big lump of meat. A big lump of meat of mass 5 kg is hung from a spring balance. Is hung from a spring balance. A big lump of meat of mass 5 kg is hung from a spring balance in an elevator. In an elevator. Find the region of the balance. Find the region of the balance. Class, anytime you hear elevator or lift, just know that this is the formula. Find the balance of the region. Find the region of the balance. Find the region of the balance. Find the region of the balance. If the elevator is moving with a steady speed. If the elevator is moving with a steady speed, make sure you're writing this question down. Remember, you're still in a class. If the elevator is moving in a steady speed, the elevator is moving upwards. The elevator is moving upwards. with acceleration of 0.2 meter per second square. Take g as 10 meter per second square. With acceleration of 0.2 meter per second square. Take g as 10 meter per second square. Take g as 10 meter per second square. Yes, yes, yes. Another question. We have two questions. Another question. Two questions, then we'll go and rest. Two assignments. They are assignments which we are going to take tomorrow. Another question. Quickly, quickly, quickly. Question 2. Quickly. You have done well. If you are still in this class till now, well done, well done, well done. I'll soon release you. Well done. If you are still in this class till now, well done, well done, well done. Question 2. So this question 1. Question 1 asks I and I. Question 2 now. An elevator is moving downwards. An elevator is moving downwards with a 70 kg man. Find the net force and the man's apparent weight. Find the net force and the man's apparent weight. If the acceleration of the lift, if the acceleration of the lift, if the acceleration of the lifts as the elevator moves down, is 3 meter per second square. Is 3 meter per second square. Is 3 meter per second square. If the acceleration of the lift as the elevator moves down is 3 meter per second square. I hope you can see the board. It's 3 meter per second square. Yes, that's assignment for tomorrow. If you stay to the end of this class, well done. You did very well. You have not yet subscribed to our channel. Hit the subscribe button so that anytime we come live, you will always be the first to know. If all our subscribed members, there's some people that as soon as I came live, someone says, I do give away. After standing for 2 hours, I should do give away. Imagine. Some people are funny. Okay. So please, as I was saying, follow the YouTube channel so that anytime we post classes, you'll be the first to easily know. Are we together? Yes. So write the assignment down, and then we are done for today. We'll see you in our next class tomorrow. Please try and be consistent with the class to help you. You can see that you're learning. You can see you are learning. And if this continues, it means that when school resumes, this should be good news to your ears. It means that we can be learning in the night like this. When school resumes and maybe we are tired, we cannot do physical class. Instead of stressing ourselves, sometimes you're in one far lecture and you have to go and start walking down for tutorial. You understand the stress and everything. We can be meeting online like this. Are we together? Yes. Some of you that have not registered with us, please do and register. It will not be open to everybody forever. This class will not be open to everybody forever. Join and register. Message me. You have my WhatsApp number. Let me drop my WhatsApp number on the board again. Message me, join, sir. Please let me register. I like this. We'll teach you mathematics. We're going to do chemistry. We'll do physics. Everything you are covered. Let me drop my phone number. Message me, sir. Can I register? Don't wait till we start selecting those that have not registered out. This is my WhatsApp. My WhatsApp number. Message me, sir. Please let me register for this class, because very soon now, there's a way I can do this live that only my registered members. I will just change it to private. Why everybody can join this live now is that I put it in public. I can set it to private, and then I will only pick my members and say, come. But if you're not my member, I will remove you, because I can see everybody's name. You send me your username. I can say everybody's name. We have Richard. You just tell me your username. Anybody that's registered with me, tell me your username. I will know. So if you're not part of my member, I will remove you from my life. You understand? But this one, we say let everybody join so you can see the benefit. You can see that it's possible. You can see what you are paying for. It's not a scam. Are we together? It's not, thank you. Someone gave me 400 again. Maxi, thank you, thank you. So I'm just saying 400 something gifts. Yes, thank you. Are we together? You can see that this is life. It's not something that, because some of you will say register or pay for the online class. Say, they maybe don't want to dupe you or anything. This is life. You're seeing me teaching life. There's no better evidence than that. Are we together? So I want why I open this to everybody is that so you can see that the class is serious and we're teaching actually. So this class will really help you when school resumes, when they give you tough assignments, tests. This class really help you. Any smart students that have not registered with us, say, let me register. If you are in this online class and you've paid, you don't need to even be thinking of stressing yourself in physical class. When you understand, no matter your department, you can join us and register if you have not yet registered. Are we together? Yes. So tomorrow by 9 p.m., we're doing it 9 p.m. every night. Why I did 9 p.m. is that 8 p.m. I have JAM class. I used to do JAM class 8 to 9. If you have any of your brother that is writing JAM, direct them to us. We teach them JAM every night too. So before I came to teach you, I was standing for 1 hour teaching JAM students first. I was live for my JAM class. You have a brother writing JAM, no matter where they are, they can learn with us. Are we together? No matter where they are in the country. Yes, a live class, I'll teach them like this live. Yes. You can give them my number or message me. Let me send you the group link. We have a JAM group link. If you know anybody that is writing JAM, your friend, your sister, your brother, yes, send them, message me, sir, please, can I add my brother? He's not in Port Harcourt, but he can join you live anywhere. Yes, let him be learning and write his JAM. Let me add my sister. Let me add my best friend, my neighbor. Yes, if you know anybody that's writing JAM, you can direct them to us. Yes, all right. So thank you very much. Good night, everyone. Good night, everyone. Good night, everyone. Enjoy your night. See you tomorrow by 9 p.m. Set the alarm. Get ready. Get ready. You want to register with us? Message me. So let me register. I like this online class. Message me. Message me. Message me. Yes. Yes. Don't wait till we start selecting only those that have registered. Are we together? All right. Thank you very much. See you tomorrow by 9 p.m. You want to register? Message me on WhatsApp now. So I have not registered, but I joined today because you allow people to join. Tomorrow I may not allow. You understand? You understand? You want to register? Message me. Message me. Yes. Okay. All right. Good night, everybody. Yes.